Hello dear learners, welcome back to Fun Scholar e-learning series. I am Rikta and we at Fun Scholar are committed to bring the best from the world of robotics and electronics to you. Hope you remember in the previous tutorial we have learned about battery. The link of the previous tutorial is in the description box. You can also watch it out just by clicking on the link popping up at the top right side of your screen right now. In the meantime, let me remind you to do like, share and subscribe to our YouTube channel for more such interesting tutorials. Today we are going to learn about capacitor. The topics which we are covering today are what is a capacitor, difference between a battery and a capacitor, symbol of capacitor and working of it, what is capacitance, unit of capacitor and the equation to measure the value of capacitance. And at the end of the tutorial, there will be a pro tip for all of you. So do watch the tutorial till the end to get that tip. A capacitor is actually an element which has the capacity to store electrical energy. Now if you can recall, in previous tutorial of battery, we have learned that a battery can also store electrical energy. Then what is the difference between a battery and a capacitor? In case of a battery, as we have learned in previous tutorial, that the chemical energy within it is transforming into electrical energy. Whereas in case of capacitor, an electric field is first created within it, and from that electric field we are getting the electrical energy. Along with it, there are some other differences. The charging and discharging of capacitor is much faster than a battery, whereas the battery can store more electrical energy than a capacitor for the same area. Now, the symbol of capacitor. When the capacitor is not charged, that is non-polarized, then it can symbolized by two parallel lines, as you can see in this picture. But when the capacitor is charged, that is polarized, then we can symbolize it by one straight line and one curved line. The straight line indicates the positive plate and the curved line indicates the negative plate of the capacitor. For variable capacitor, it can be symbolized by this symbol, whereas this arrow indicates that the value of the capacitor is not fixed, but it varies from a minimum to a maximum value. A capacitor is actually a combination of two parallel conducting plates separated by a dielectric medium. These two conducting plates are metal plates, whereas the dielectric medium between these two is actually an insulating medium. Now what is an insulator? An insulator is a material which opposes any flow of current or electron through it. Let us now discuss the working of capacitor. Here I have indicated the two plates of the capacitor by A and B. The A plate is connected to the positive terminal of the battery, whereas the B plate is connected to the negative terminal of the battery. As we know that the negative terminal shows that here are excess amount of electrons. So these electrons start flowing through this conductive path and reach plate B, which is also a conductive plate, but it cannot travel from B to A, as there is a dielectric medium between these two, and this dielectric medium works as an insulator which opposes any flow of current or electron through it. That is why the electron starts accumulating on plate B, and because of this excess amount of electrons accumulated on plate B, the plate B becomes negatively charged. Whereas by the same process, Plate A became positively charged. Because of this, there is a potential difference between these two plates, and this potential difference creates an electric field within this capacitor. And because of this electric field, a capacitor can store electrical charge or electrical energy. Now, when we disconnect the capacitor from the voltage source and connect it with a bulb, then the stored electric energy or charge within the capacitor provides the required power to the bulb to glow. Let us now discuss what is capacitance. The capacitance is the capacity of the capacitor to store the charge. If the capacitor has higher value of capacitance, that means it can store more electrical charge than a capacitor having lower value of capacitance. The unit of capacitance is farad. In general, we use smaller units like microfarad, picofarad, millifarad, etc. The value of capacitance can be measured by this simple equation C is equals to Q by V, where C indicates the capacitance of the capacitor measured in farad, Q indicates the charge stored within the capacitor which is measured in coulombs, and V indicate the value of voltage across the capacitor which is measured in volts. Now, as we have reached the end of the tutorial, so this is the time to get that pro tip. If you observe any capacitor carefully, you can see that there are two values specified for all the capacitors. One of the value is farad or microfarad, millifarad, picofarad, that is the value of capacitance, and the other value is voltage, that is denoted by volt. Here you can see the value of the capacitor is specified 47 microfarad and the value of the voltage is specified 400 volts. This value of capacitance indicates the maximum value of charge or the maximum amount of charge a capacitor can hold, and the value of the voltage indicates the maximum voltage that can be applied across the capacitor. If we apply more voltage than this specified voltage, then the capacitor will be destroyed because of the dielectric breakdown of the capacitor. So always remember, whenever you use a capacitor into any of your electronic project, don't apply voltage more than this specified voltage. Otherwise, your capacitor will be destroyed. If you like this tip, then for more such tips and tutorials, don't forget to like, share and subscribe to our YouTube channel. In the next tutorial, we are going to learn about breadboard and how to connect different electronic components on it. Till then, keep learning, be safe and keep watching Fun Scholar e-learning series. Thank you to all for watching this tutorial.